Today's paper is The Art of Practical Synchronization. It's a 2016 paper. The performance of transactional database systems is critically dependent on the efficient synchronization of in-memory data structures. The traditional approach, fine-grained locking, does not scale on modern hardware. Lock-free data structures, in contrast, scale very well but are extremely difficult to implement and often require additional indirections. In this paper, authors argue for a middle ground, that is, synchronization protocols that use locking but only sparingly. It's proposed to synchronize the adaptive radix tree aka ART using two such protocols. First is optimistic lock coupling and second is read-optimized write exclusion aka ROWEX. Both perform and scale very well while being much easier to implement than lock-free techniques. Main goal in this paper, however, is to distill general principles for synchronizing data structures in general. This paper experimentally compares a number of ART variants: unmodified ART without support for concurrent modifications, lock coupling with read-write spin locks, optimistic lock coupling, ROWEX, and hardware transactional memory with 20 restarts using a global elided lock as fallback. As a competitor, authors chose Mastery, which is the fastest publicly available synchronized order-preserving data structures. There are quite a few contributions of this paper. The paper presents two synchronization protocols for ART that have good scalability despite relying on locks. The first protocol, optimistic lock coupling, is very simple, requires few changes to the underlying data structure, and performs very well as long as conflicts are not too frequent. The read-optimized write exclusion aka ROWEX protocol is more complex but has the advantage that reads never block. ROWEX generally requires changes to the data structure itself as opposed to simply adding a lock at each node. One should not discount the use of locks as long as these locks are infrequently acquired like in the two protocols, optimistic lock coupling and ROWEX, which are two pragmatic paradigms that result in very good overall performance. Now let's give this paper a PS score. It's easy and engaging read, so on readability it gets 9 out of 10. This paper is 8 pages long and beautifully captures the essentials, so it gets 10 out of 10 on length. Readability might be a little hard, so it gets 9 out of 10. The paper has significant industry value, so it gets 9 out of 10. The paper presents neat techniques around synchronization, so on learning meter, I'll give it 9 out of 10. So the final PS score is 9 out of 10.